All right, welcome back to your favorite pre-calc class. We're going to take a look now at systems of nonlinear equations. We're going to continue to use elimination and substitution, the algebraic approaches to solving, but this time they're not lines. They're not linear in style. We could have quadratics or frankly anything, and we're still going to solve them algebraically. I will give you a visual as well periodically so you can see how they are visually. But let's take a look at this first one. In this one, I'm looking at it and I'm like, gosh, should I use elimination or substitution? Well, I notice in the first one, y is already solved for. I already have y is equal to x minus 5. So what I'm going to do, so this is by substitution, I'm going to take that second one, x squared minus y squared. I'm going to plug that y in. Here's my y. I'm going to plug it in. And let's go ahead and solve this now. So we got x squared minus, I got to go ahead and expand this. Notice those are gone, so I have 10x minus 25 equals 5. Add the 25 both sides. 10x equals 30 divided by 10. So it looks like x is 3. So then we say, oh, well, I know x is 3. This has to satisfy both equations. Has to satisfy both. So notice if I put it into this one, 3, I have 9 minus y squared equals 5. To subtract 9, so I got negative 4 divided by negative 1. And I get two possible solutions, but remember, it's got to satisfy both. So 3, 2, 3, negative 2. Let's do it in the other one. Y equals x minus 5. Well, if I plug 3 in there, I got 3 minus 5 or negative 2. So I can't include the positive 2 because it has to satisfy both of the original equations. So it's only the 3, negative 2. Only the 3, negative 2. Okay. Visually, what's going on, again, I'm not expecting you to know what this looks like visually, because one of these is a hyperbola, the other one's a line. The line would be no issues, but the hyperbola you talk about in your next course. But it is valuable to take a look at both of these visually. Here's the first one, y equals x minus 5. There's our line in red. The second one's a hyperbola, x squared minus y squared equals 5. And notice these two hit right here at that point, 3, negative 2. That's where they intersect. That's the only place that they intersect. They do not intersect at 3, 2, right? They only intersect at the one spot, 3, negative 2. Taking a look at this one, I would also solve this for a variable. I would probably take x on the bottom and I'd use substitution again. So let's use substitution because that bottom one, x is real easy to solve for. I just subtract 2, negative 2y. So x is negative 2y. So then I use the top one, xy equals negative 2, and I go ahead and plug that x in. So I have negative 2y times y equals negative 2. So I get negative 2y squared equals negative 2. I go ahead and divide both sides by negative 2. Y squared equals 1, square root. So y could be plus or minus square root of 1, which is 1. Okay? So since we have two values of x here, or y, sorry. So if y is 1, and I could plug it into either of those. X is negative 2y, or xy equals negative 2. Oops. So x is negative 2. So when y is 1, x is negative 2. And notice if I plug that y equaling 1 into the bottom one, it would also give us that. Well, y was not only 1, it was -1 as well. So y could be -1. Again, I could plug it into either one. Either one will spit out the same x value here. Divide by -1. X is 2. So when y is -1, x is 2. So both of those. -2, 1, and 2, -1. Okay. Get a little visual on that one as well. Here's our rational function. And here's our line. And there's where they hit. -2, 1. And 2, -1. Okay. All right, let's move on to one where we have both of them here being, notice the x is squared, the y's are squared on both of them. I would, instead of solve, if I was to solve for a variable, I would have to square root both sides, and then I'd have like y equals plus or minus something. It'd be a total mess by substitution. So I think the way to go with this would be elimination. So I would go ahead and line these up. And let's go ahead and let's get rid of the y's. So the bottom is 3y squared, the top is -1 squared. I just got to multiply this by 3, and then I'll eliminate the y variable. Notice that's gone. So now we have 5x squared equals 5. Divide by 5 on both sides. Square root. So x could be plus or minus 1 on this. And so if x is 1, now we're going to go back to either of the equations here. Let's go with x being 1. I'm going to plug it into x squared minus y squared equals 0. 1 squared minus y squared equals 0. So y squared is 1. Square root, so y could be plus or minus 1. So when x is 1, y is plus or minus 1. Now I have to also consider when x is -1. And by the way, when you plug it into 2x squared plus 3y squared equals 5, you would also get plus or minus 1 on that last one. Same thing here. So when x is -1, you have plus or minus 1. So you have 4 answers. You got 1, 1. You got 1 with the -1. And then you've got -1 with the positive 1. And you got -1 with the -1. Okay, you could also take a look at that visually if you choose to. Let's take a look at this next one here. X squared plus y squared equals 10. I'm going to go ahead and use elimination again. And notice on this one, the y's cancel. So what I have is 3x squared equals 9. Divide by 3. Then x squared equals 3. So I could square root on that. Oh, I'm so sorry. That's not a y squared. That's 2x squared minus y. I just realized that's not a y squared. That's just a y right there. Sorry about that, you guys. Try that again. Let me copy it correctly. 2x squared minus y. There we go. Is -1. Well, I obviously can't cancel y squared because y squared minus y, they can't combine those, so they won't cancel. But I could get rid of the x squared. So let's do that. So let's multiply this by -2, and then I'll be rid of the x's. -2x squared minus 2y squared equals -20. And then the bottom here, I'll have 2x squared minus y equals -1. Again, the x squareds are gone, which is nice. So now I have 2y squared minus y equals -21. So I'm solving a quadratic. Oops, that's a -2y squared. Sorry, minus y equals -21. So I go ahead and let's get one side equal to 0. So let me add 2y squared to both sides. Let me add y to both sides. So I have, let me come over here, 0 equals 2y squared plus y minus 21. So this will, I think this will factor. So 2y and y. And we could go 7 and 3. Let's see, that'd be a plus, that'd be a minus. Let me double check that. 2y squared minus 6y plus 7y minus 20. There we go. Set each one equal to 0. So 2y plus 7 equals 0. Y minus 3 equals 0. So we got y equals 3 or y equals -7/2. Okay. So we need to check both of those. So let's start with y being -7/2. Okay. If y is -7/2, let's go ahead and plug it into 2x squared minus y. And I'm going to put it into the more restricting one. This one only has a y. This one has a y squared. So the y squared one will pop out 2 answers. The y will only pop out 1 answer. So I'm going to pick the one with just a y. 2x squared minus y equals -1. I'm going to plug that in. So 2x squared plus 7/2 equals -1. I'm going to subtract 7/2. So I have 2x squared equals -2/2 minus 7/2. That's a -9/2. I'm going to divide by 2. So -9/4. Square root. Well, that would be plus or minus 3i/2. Well, we're not working with imaginary numbers. We're not working with those in this section. We're only trying to find the solutions, the real solutions. So we can go ahead and throw out -7/2. That's not going to work. So how about y equaling 3? That has some potential solutions. Let's throw those in. Add 3. Divide by 2, divide by 2. Square root. So x is plus or minus 1 when y is 3. Plus or minus 1 when y is 3. So we have 2 solutions. So we have 1, 3, and -1, 3 would be our solutions for this. 1, 3, -1, 3. Let's move on here to our next one. We'll go ahead and do this one. We got y equals -√x, and x plus -3 squared plus y squared equals 5. I'm looking at that and I'm like, man, I'm going to use substitution because I already know y is equal to -√x. It's already solved for. So I'm just going to throw that in right there for y. So I'll have x minus 3 squared plus y squared equals 5, and our y is -√x. So let's see what we get here. X minus 3 squared plus -√x times -√x is a positive. Root x is x. So we have x squared minus 6x plus 9 plus x equals 5. -6x plus x is -5x. Subtract 5 on both sides. And factor. So we could have x being 1 and x being 4. And I'm going to go ahead and plug that into the more restricting one. In other words, if I was to plug it into this one for x, If I plug it into that, notice the y squared. I'm going to pop out two solutions. So I'm not going to plug it into that one. I'm going to plug it into y equals negative root x because it's only going to pop out one. Remember, it's got to satisfy both solutions. So the more restricting one, if that makes sense, is the one you want to use if there's a choice. Or you could just plug them into both and see if what values satisfy both equations. So when x is 1, y is negative 1. When x is 4, y is negative root 4, which is negative 2. When x is 4, y is negative 2. So 1, negative 1, 4, negative 2. I'd like to look at this one visually. It's kind of a nice one. Y is negative root x. Let me clear this and this. Here's the square root function flipped around the x-axis. Reflected about the x-axis. The next one was a circle. X minus 3 quantity squared plus y squared equals 5. So it's a circle with the x, remember, x minus h quantity squared plus y minus k quantity squared equals r squared. So that's a circle at the point 3, 0 is the center of that with a radius that's the square root of 5. So radius is 2 point something. And you see that in red there. And here's where they hit. 1, negative 1 and 4, negative 2 as we solved that. All right. All right, let's do this one last one here. We've got 5 over x squared minus 2 over x squared, 2 over y squared equals negative 3. And what I'm going to do is I'm going to let u be this and v be that. In other words, I have 5 times this minus 2 times that equals negative 3. So it's 5u minus 2v equals negative 3. The other one would be, the lower one would be 3u plus 1v equals 7. And so I'm going to use that. I'm going to simplify it that way. And I could solve this. I'll probably do, I don't know. Let's do elimination. Let's get rid of the v. So I have a negative 2v on the top. I have a positive v on the bottom. So I just need to multiply this by 2 and I'll be okay. 6u plus 2v equals 14. And then I'm not dealing with all these fractions, right? By making that substitution at the beginning. That's gone. So I got 11u equals 11 divided by 11. So u is 11, right? So if u is, I'm sorry, u is 11. 11 divided by 11 is 1. Good grief. U is 1, right? So we have u being 1. So let's go ahead and solve for v now. So if no u is 1, then we can plug it into either one. How about that top one? 5u minus 2v equals negative 3. 5 times 1 minus 2v equals negative 3. Subtract 5 both sides. I got negative 2v equals negative 8. Divide by negative 2, I got v is 4. Okay? Now, u is 1 over x squared, if you remember, right? Well, we know u is 1. So 1 equals 1 over x squared. Let's multiply both sides by x squared. So we have x squared equals 1. So x is plus or minus 1. Now we know v is 4. V is 4, but remember v is 1 over y squared. So multiply both sides by y squared. Y squared divided by 4, 1/4, square root. So y equals plus or minus 1/2. Square root of 1 over square root of 4. Okay, so here's our solutions. We got 1, x is 1, plus or minus 1. So 1 with the positive 1/2. 1 with the negative 1/2. Now x being negative 1 with the positive y of 1/2. X being negative 1 with the negative 1/2. And of course, you could take a look at that visual as well. That's probably the easiest way to go about that is make that substitution with u and v. And that's a little overview of systems of nonlinear equations. Thanks for taking notes. See you next time.